Welcome to a lesson with Dr. Powell. Let's take a look at another example of telling if a function is even or odd algebraically. Suppose we have something like this. F of x is equal to x times the absolute value of x plus x cubed. Okay, now, again, we're going to check to see what happens to the function when we do a reflection this way across the y-axis, meaning that we multiply all our x's by -1. So we go through and multiply all our x's by -1. And see what the resulting equation will look like. Okay, and see how it relates to this one right here. Well, if we work through this, maybe we can get the negatives, at least in their proper form, or maybe outside of things a little bit better. See how this negative is inside this cube. So we do deal with this the same way as we did before. The 3 can distribute to this -1. So this is like -1 times x. -1 cubed times x cubed. And then absolute values, we can ignore the negative right there, x. And then here, this is just -x. This is just negative, so we could rewrite this as -x absolute value of x minus x cubed. Okay, now let's try the other reflection and see if we get the same thing. So the other reflection means we multiply our y values by -1. So if we multiplied our y value by -1, we would have, let's work with the original. We start from the original one again, because we're working from the original and seeing what happens when we reflect it that way. So this is like a y equals. So let's multiply that y by a negative. We would get this, but if we wanted to, we could multiply both sides by negative and we'd end up getting y equals -x, absolute value of x minus x cubed. Wait a minute. Reflection across the x-axis, which is this right here, replacing y with -y, look what it did. It gave us the exact same equation as we got when we multiplied all our x's by negative. Wow, look, see how these two things are the exact same? That means that this reflection is the same as that reflection. Hey, that's odd that the two reflections are the same. Now, if the two different reflections are the same, but it doesn't get us back to the original, right? But it gets us to something else, but these happen to be the same. Then what we say is that that's kind of an odd symmetry. It's odd. Okay, we say this is an odd function. Thanks for watching.